Thank you, Mara, and thanks for the invite. With the agenda here, I'm just going to give you a brief introduction to Kobold Completions, who we are, talk a little bit about the team members, and then the bulk of what I'm going to talk about is the goals of the project, both in terms of the technical and the cultural side of things. One of the things I was really glad to hear about with a lot of the sessions that I've been sitting in is, the human in the loop and the people side of things. We're technology guys, people, geeks, so we much prefer to talk about the technology and that side of things. So first of all, Kobold Completions, we're an oil and gas service company. We have downhole technology for completions to make the oil production a lot more efficient and more cost effective. And we've been in business for about 15 years. I was brought onto Kobold just under 3 years ago with the goal of bringing my background with data architecture and software architecture to really do a bit of a digital transformation of Kobold and our data and what we're doing. So it's going to be a long road, and some of what I'm going to share is the journey and the challenges of applying advanced analytics and getting a traditional company into the digital age. So the team members, we actually had a good-sized team here, and I've two of them. Peng is the lead software developer. He's here for questions on that side, and Sahand, if with any tough on the ML questions, I'm going to defer to those guys. As well, we also had an application developer, but more importantly, or just as important, it was the whole team. So we brought people in on the hardware engineering side that were familiar with the data. So it ended up really being quite a multidisciplinary team. And then even on the Amii side, what was really nice is that Sahand had support from Jaber on the technical side, and then Deborah as a project manager. So really smooth, traditional process. We had weekly stand-ups on that team and with the Amii side. So lots of cross-communication. So just jumping into the goals of the project. And I am going to spend the last half of my talk talking about the technical side of things. But really, the bottom line and our goal of the project is we collect a lot of data at Kobold. And it takes days after the job is over to analyze it and be able to make decisions. And in fact, with our customers, 2 days is too late. They've already moved the rig to another well, and if they need to make changes to their drilling program based on the job that was just run, they need to know as soon as the job is over. So moving it towards, being minutes rather than days as the project. So the second part is really the cultural side of things. This so gets overlooked with a lot of technical projects. So one of the things, and for those of you just starting your career or early in your career with technology, you may have heard numbers like this before, but 70% or more of technology projects fail. And it's not just data science ones, it's pretty much anytime you're looking to do innovation. The reality is people don't like change. And by definition, you as a group of people that are interested in AI and innovation and technology, I got to assume that 99% of you love change, like bring it on. But with a lot of who are going to be your consumers or end users of what you're producing, they're like, it didn't work out so well last time. They're quite. There can be one of your biggest challenges. And in fact, I've got some links in my presentation, in particular to this, a fairly recent study on, why a lot of projects do fail. And they're not technical. It's people and culture. So some of the things that you want to do with your projects is include stakeholders early on and often. One of the things that will be a quick demise is you go out, talk to your end users, your stakeholders, you come up with an idea and go away and develop it for 6 months, and then, proudly show it to them, and they're going to say, that's not what we said. One of the things that I learned early on software rollouts is I would send 2 people out when we would do major releases. I would send one of the leads on the software team, and I would send a support person to literally watch how our changes or new application got changed and how it was received. And 9 times out of 10, software engineer would come back and say, oh, that's how they're using it, and make some code that would actually, then start to delight them. Over communicating. If I was ever going to be a business consultant, I would go into a company for 3 months, make them pay me a bunch of money, and then I would say, you know what, you need to communicate more. It's epidemic with most companies where they're not communicating goals and structure enough. I already talked about the integration of our teams, but we made sure that we were integrated with the end user. We actually, Glenn, who is responsible for the front-end application, actually sits in on the operations stand-up meetings on a daily basis. One of my favorite writers, Stephen Blank, on some of his books on innovation, every chapter pretty much starts with get out of the office, get out from behind your desk and see what the end users are doing. One of the other parts that we paid a lot of attention to, and it's really the cultural change, and I stole this chart from our health and safety guy. This is a fairly standard chart that defines a safety culture of an organization, and it occurred to me that this works really well with how the company is using data. Like, I think every department could actually have this sort of chart. And really, from the left-hand side, it starts with, we're just ignoring it. We're sticking our heads in the sand. Kobold, when I first joined, we were pretty much using data to find out what went wrong. Very much, it's used to cover your ass, CYA, on that side of things. But part of our goal, if you're working with an organization or a department and they're using data for just, covering your ass, then, you as a data scientist or somebody that's really interested in this, really your goal is number 5, to become a leader. In our case, when we were doing the project, really wanted to get to the stage 4 where we were using data for predictive events, for being able to see what's coming down the road and improve processes. So, making sure that everybody in the company is wanting to work towards using data for being proactive versus reactive is the stage that we really wanted to get to. And I actually do, in the presentation, I have a link to where this came from too. So, switching over here, actually there was one thing I did wanted to say here on the cultural side of things. In one of our stand-up meetings, Glenn, he was talking about his previous day, and he pretty much spent it with users and going over things, and his comment was, I didn't get any work done. I was peopling all day. And something that kind of occurred to me is, us as technical people, if we're not writing code or dealing with data, in front of our screen, we don't think we're doing work. So one of the things that's really important for projects and for them to be successful is you have to realize that communicating what's in your head and what's on your screen and giving back the feedback to the users, what you think you heard them say and what you think you heard them on what they want, you can't do that enough. I skipped over it on there, and I think I had a link on one of the previous slides to the agile principles. You know, you hear a lot about agile methodology, but in the link I actually have to the 12 core agile principles, which are really about communicating, over-communicating, delivering code rapidly for user feedback, which is about communicating, and a lot of those. So it's really important to keep those that in mind. So technical side of things. So Kobold, when I joined, almost all of the processes were very different silos, different applications. And one of the things that you hear of or you've experienced is that 80% of most machine learning projects is actually data presentation, data preparation. 80% is probably a good one. You know, I think a lot of them, one of the things that was really good with Amii is we had some pre-meetings with them on the project and talked a lot about the data preparation, and they had a good roadmap of where we needed to be and where we needed to go for the machine learning. So one of the things that we did was kind of roadmapped where we were and where we needed to go. One of the things throughout my career as a data and software architect is I've always started with the data structure, and a lot of times with the reports that you need to be outputted at the very end. There was a little bit of a hiccup in my roadmap where I was convinced on one application where we did code first, and then we let the code. Microsoft has some great tools that I think are evil that let you do code first and then develop and then it puts in the data structure for you. Go with data structure first, and that's so much more true with machine learning and advanced analytics. Making sure that you've got a sound data structure, because you going back and fixing your data structure is, you know, it will cost a lot. Processes. The other thing to do is are you looking to improve? You know, finding out where the bottlenecks are, where's the low-hanging fruit. I purposely have a circle in my roadmap here because pretty much every one of these steps is going to be iterative and ongoing. I've actually got, you know, getting to automation after we define what the processes are, and then really getting to the advanced analytics and the real-time integration. One of the things too with projects that I learned early on, people get enamored with technology, and companies or departments will realize they have a problem, and their first step is to put some technology in place, and that'll just solve everything. Drives me nuts. You know, what you really need to do is define what your process is, define what the problems are, and then find the best tools. Because, you know, technology just helps you fail faster if you don't put it in place in the proper order. So we really tried to define those. So just a little bit of the background. Previous to this, my previous projects, we almost used completely all open source. We were with AWS and used a lot of their stuff. With Kobold, we were already deeply a Microsoft shop, and it was, I had some experience with Microsoft Azure, but Microsoft has really done some cool things and quite powerful, and allowed us to scale up quite quickly. You know, they used to be they were very anti-open source, but with their new CEO, he's really brought in where you can bring in different open source solutions. So one of the things too, when you're looking at where to improve, a boss of mine a while ago, he taught me the quote to cash. He says, you know, if it isn't somewhere along the quote to cash, i.e. it's where the company is responsible for either spending money or making money, just ignore it. You know, it's not a process that you're going to get a lot of buy-in and where you want to. And if you're on the entrepreneurial side, I've heard some of the other talks, it's looking for problems to solve. It's not just looking for problems to solve, but really, unless you're in academia, you really want to look for problems to solve that people will pay you to solve. So the quote to cash is a great, as long as you know how companies get from the beginning to getting money in the end, that's the place to follow and start. The automation on that, we just really identified the low-hanging fruit places. It's easy when you're using a bunch of Excel. We just look for places to punt Excel. So, and then the real-time collection and monitoring, I'll talk a little bit more about that down the road. And then finally getting to where we could get the advanced analytics and the ML. The important part about this, and even though it's a very iterative process and you go back and forth, you've got to get all of this work done to really get to where you can do an effective machine learning project. Making sure what this covers off is on the company's goals. The quote to cash shows you the roadmap. So if you're not doing advanced analytics on something along processes along that line, nobody's going to care about it. And then when I actually did this, the roadmap when we first started, so late 2020. I missed a really important step on this whole thing too, and it is the commercialization side of the whole project. One of the things that's nice about ours is we're literally just now in the stage where for the last half of this year, well, we're going to be getting some commercial revenue off of what we're doing. So what are we doing? This is a screenshot of one of our service trailers, which is on site with it, and these trailers are a data disaster on that. In the picture we have 3 laptops. One of them, so I'll talk about Echo display, spreadsheets from what's going on with the job, and then as well we've got a data feed coming in from the coil and frac vans in there, and as well, in addition to this, there's like 2 radios on site, limited internet access. Our project changed because of that, but and part of the reason why it took days to do analytics is our downhole sensors, huge amount of data that we had to send back to Calgary to be processed by an engineer in Calgary in order, for a chart and an analysis to be done. And actually the engineer that did most of it lives in Victoria, so there's even some other complexities. And of course you got to have your music in your van too, so we had Google Play display. So one of the things that we were looking to do here is, first of all, using edge computers, so moving edge computers into our service trailers. Part of this is the original project. We have limited internet access. We do a lot of our jobs in southern Manitoba or northern Alberta where there's just dark zones of internet. I mean, there's even places where it's a health and safety issue because there's not even cell access. So one of the things through the project, Elon Musk's RV Starlinks, we ended up equipping all of our trailers with those and ended up with a great data feed. So our original project with wanting to do store and forward with our edge devices ended up kind of going away. So an important part of the process is also creating the applications to capture the data rather than dumping it into Excel spreadsheets. Literally previous to this, we had Python scraping code to pull it from the spreadsheets to load it into our database. But of course, every time operations changed a column, that messed things up. So the scoping of the project. This was another really important step where we took quite a bit of time on this. This is, even though we had a fairly senior team, I think like half of us have master's degrees in our area, probably more than that. But, we were a little bit out of our element with the machine learning side of things. So we brainstormed a number of different projects, and this was another one where we used the opportunity. We had operations and engineering as part of the brainstorming process, and in fact, it was an engineering suggestion that we ended up going with. Some of the characteristics that we wanted to go with is that we wanted to make sure that it was data that we controlled. I've been involved in a number of projects where, we were involving third-party data, and Mike, who's going to talk next, we were just talking about those, and both of us have scars from projects where, having to rely on a third party for your data. So one of the things that's really important, and literally this is grade 10 science, the scientific method, is you want to eliminate as many variables as you can. Our goal was this first phase of the project, we wanted to make sure, we were fairly successful with the machine learning, or we thought we were we had a chance of being successful on the machine learning side of things. So no human entered data. It was strictly, we went with data from our 2 sensors. And then the other I had already mentioned, we contacted Amii fairly early on in the project. I hadn't worked with Amii before, but being in technology and in Alberta, you can't help but come across them on a regular basis. And, they did a really good job of setting up what our expectations and what was possible. So that was really good. And then the other one too, which was a real nice boon and helped reduce the risk, is we ended up with an Alberta Innovates DICE grant that to help take some of the risk out when I had to go to my boss to say, we want to spend $900,000 on this. So, the data that we were dealing with. Kobold, not to go into a lot of detail, but basically what we do in the oil and gas industry on the completions, there's 2, the most popular method of doing wells is called plug and perf. And basically it's where they blow holes in the side of the pipe to let the oil come in to flow up to the surface. Kobold, we have slidable sleeves that companies can open and close as they deem fit. One of the things that the companies try to avoid is having too much water coming in from the different zones. So having sleeves that you can actually identify where your water zones are and closing them makes them a lot more efficient. So part of our process for opening sleeves is that we send tools downhole at the end of a coiled tubing string and latches on and moves the sleeve up and down. As part of our bottom hole assembly, we have a tool called Guidehawk, which is basically a sensor, a bunch of sensors that are collecting pressure, shock, strain, there's direction, those sorts of things. So really, we can tell exactly what's going on downhole when we're trying to shift the sleeves. So it's very accurate. However, there isn't a feasible way to communicate to the surface. It's a memory tool, so we really don't know what went on in a lot of detail until we pull it to surface. Now, I say there isn't a feasible way. There is a way to do it, but oil and gas companies don't want to pay for wireline downhole that has the electronics to send it to the surface. So it's historical data. This is an example of once we bring it to surface, just a chart with all of the different readings. So the second sensor we have is echo, and it's basically just a geophone that's recording the vibration. We strap it to the wellhead, and it's reading vibration and shock from what's going on downhole. So this literally is an example of the from a job, what the echo device is reading. Now it's at the surface, so it's a real-time tool. And is this my back? There we are. It's the big red button. All right. So whereas we get a lot of detail on the downhole, echo doesn't give us the detail that we need to be sure that a sleeve has shifted. The other part about it is that it really relies on a technical, our field hand has to have a lot of experience to indicate a sleeve has shifted. Now, on one hand, it doesn't take too much. Like the field guy is probably 80% accurate for when the sleeve shifts. One of the things with this project, though, if they're wrong, it's really costly to us. What ends up happening is our customer, the oil and gas company, thinks the sleeve's open and thinks it's producing oil, but it's not. So the risk to our reputation is huge when we get that wrong. One of the things with a lot of industries, oil and gas seems to be particularly bad about it too. There's a lot of finger pointing when things go wrong, so part of the reason to use data is to find out which of the service providers, because any given job, there's us, there's the coil company, there's the frac company, there's the geologist, so there's a whole bunch of people on site that might have got something wrong. So one of the things with the project, and this was one of the coolest learning, one of the first learning things, when we first started the project, we figured we could write a simple algorithm to indicate where the sleeve shifts are. What we were going to do is use the guide hawk data and overlay it onto the echo data to use guide hawk to train echo on sleeve shifts. So, echo knows when they are, guide knows where they are, echo didn't. So that was the original scope of the project. One of the things when Sahan joined us, we were at this stage where we were trying to write the algorithm, and this is actually our algorithm. The black dots there are indicating where it shows a sleeve shift. And Sahan, one of the things when we were onboarding him, he knew all of the processes and what was going on. And one of the first things he suggested was, why don't we use machine learning for doing the prediction of the sleeve shifts? So to Alan, the guy that was doing all this, was great relief to him. It got him out of having to do a whole bunch of these by hand and double checking his work. So the other thing that was really positive about this, and part of having our data ready at the beginning of the project, mostly ready, Sahan was able to start working. I think after your onboarding, it was like 2 weeks and you were starting to write code. That was one of the things, I think when Amii first onboarded us, they said it was going to take 3 months and before we would get to the ML side of things. So getting all of your data and your processes and your onboarding in place earlier on really helped us do some stretch goals with the project too. So with Sahan and you've got more of the technical questions on these at the end, I'm going to go over to him, but he was able to go through a number of different models with both the guide and the echo data. And what was really interesting about it is we didn't even have to use guide hawk to train echo, although we actually are using that data, and there's going to be some other interesting uses down the road for it too. So with a couple of the things, being able to try a bunch of different iterations with our data and our models, we were able to be able to pick and get to the one that was going to give us the best results. One of the cool things too about the project, and making sure that you give yourself a lot of time, is that our first training set was based on just one customer in one basin. And then when we brought in another training set from a different customer in a different basin, the numbers just plummeted, 20% for this, something like that. So one of the things that we were thinking about is, do we have to have a number of different models depending on the basin? But because we had enough time, Sahand was able to experiment with the different models and with different basins and with different customers to see how they did. So in the end, we were able to just go with the XG boost and using it for both echo and guide. So when we're, and then this is a little bit diving into the details of what we're actually able to get from it. We end up with, in our database, we're storing a whole bunch of different variables in there, and we are looking at echo data in this case. And one of the things that we were really looking to do is kind of get to the binary yes or no, or what's the percentage of surety that we have. And we ended up with both of the values in there. So we're able to get, here's the example of indicating where we knew within 87% whether a sleeve shifted or not. So with this, the cool part about it is there was actually a couple of things that we learned from our data even that our engineering team didn't know or suspect, and we got to do a little bit more work to try this out. But these are both, this is echo and the ML results side by side. And in the field, we actually figured those big spikes were actually the sleeve shifts in the model, and it makes more sense. One of the things when our sleeves shift, they're producing something like 50 Gs of force. So literally, if you're in the coiled tubing truck, it shakes. But what we actually found out is that the earliest little blip was actually when the sleeve shift happens. One of the things, and I think you were the one that was talking about this, Sahand, is that when we're looking at the vibration and interpreting the results of it, the vibration from the 50 G shift is going to travel up the pipe way quicker than the recoil of the tubing. So, and the tubing when it recoils is really noisy, banging against the pipe and producing the big spikes. So some of our future projects that we're looking for, we have some interventionless technology, fancy way of saying we're not putting the coiled tubing down the hole. So we're actually going to lose the capability of guide hawk and being able to double check those sensors. So one of our projects down the road is to do a lot more analysis on the signal that we're getting from echo. So some of the learnings from this, to reiterate what we've did, is that really glad that we picked machine-generated data. So we did as much as I said at the beginning, don't forget the human in the loop. It was really good that we got the human out of the loop for the first project, and and it was one that needed to be completely in our control. We had enough changes and things going on, having to rely on a third party wouldn't have made this as successful. And there was a little bit of a learning on this too. When we were going into the project, I really was expecting, Sahand, I really was expecting a 100% yes or no, the sleeve shifted, and really what we're going to get is a probability of the sleeve having shifted. So the next stage, and actually the first one on this, where we're inserting the data into our tour sheets and syncing it with other data, is very much our commercialization stage, where our customers, it's not just us as one of the service company that's taking 2 days to get data back on a job, it's also our customers. It's taking them that length of time too. So really our on-site trailers, we're turning them into data hubs. And the goal is to be able to collect and analyze data from other sources on site. So the comparing echo and guide on an ongoing basis is, until we don't have guide downhole anymore, is the other one. Really understanding some of the other data going down. One of the ones most immediately is before we do a job, we do a tubing force analysis, which is basically, we're doing a model of how much force it takes to get the tube from the coiled tubing from the top to the bottom of the hole. In order to, you can imagine some of these, the wells that we do, I think 3,500 meters, and the tubing's 4 inches, so it's not even, it's fairly solid steel tubing. It takes a lot of pressure to get it down hole. So companies use some friction reducer, which is really expensive. So what we're going to be able to do is be able to compare what we predicted the force is to what the force actually was on the hole, and whether a company needed to use more friction reducer, or the best case scenario is use less friction reducer. So driving the cost and making sure the completion is a lot more efficient on that. So, and the other side of it is being able to do that as soon as the job's over. So they can actually, for the next one, they can change their completions program. So that's the project in a nutshell here. So open up the floor to additional questions. Thank you. Go ahead. Do you have
Yeah, so you were talking about identifying where you can see the business outcome in the quote to sales process. In this project, where are you guys going to see that business outcome by using machine learning?
Good question. It's very much towards the with our customers and being able to save them money. So, and part of the quote to cash is we charge an additional amount for running the Guidehawk sensors and looking to add a lot more value to the information post-job. So that's where we're, in the short term, where we're looking to increase revenue. The other part about this is that we've been able to, the machine learning was a small part of this project. Getting the whole data architecture and the applications in place was huge. We actually did something really different too. We ended up using, the original project called for us building a web front end to do out in the field. With sketchy internet, that just, it meant we were going to have a web server on site to be able to deliver from there. We ended up using Microsoft Access as the front end for this, because it ended up being a really quick development tool, and we collect way more data than we could have through a web interface. So, we say the efficiencies, it used to take us something like 8 hours to prepare for a job, where now operations prepares in 10 minutes. Really cut that down. So, yeah. Sure. Yes. So that we will have the technical paper coming out later this summer on the project, and I gave you quite a bit of time there saying later summer, Sahand, but I think that's on target, which really discusses in detail the different models that were used and the results that we got from them. Yeah. Does that cover that off well, Sahand? Yeah. Cool.
Just to note, if you have any questions, please raise your hand and I'll get you a mic.
Cool.
So I had a question. Losing your sensor data, like your real-time telemetry that's coming from the Guidehawk, are you confident on the machine learning model to deliver something in basically a replacement for that sensor data, or do you need to constantly retrain the model with new data?
You know, I think with the results we've got to date, we aren't necessarily going to do some retraining. However, it's probably going to be more on echo where we focus on the training. The guide hawk, you know, being the sensor that it is, it's pretty straightforward. There probably isn't going to be a lot more improvement. It's probably going to be a diminishing cost. However, the echo being the real time on surface, and you know, from the pictures, it literally looks fuzzy. Being able to predict additional things. In fact, actually, there was one thing that I glossed over or didn't. One of the things with the echo data, originally we were just looking at the sleeve shift, but when we were analyzing a little bit further, we actually knew the frac period, which is the green section. You know, no data is complete unless you have a weird outlier, so that one outlier in there. And then the other orange one is the transition time. So we were actually able to get a little bit more out of the echo data than we had planned for. So I think being able to do more, and the echo data is really cheap, you know, with it, whereas guide hawk is an expensive sensor. So, yeah.
Thank you. So I have an additional question. Are you guys worried about model drift over time, or you talked about using it in different settings, like in different basins? Are you going to continue to validate your model over time to know that things aren't changing? Or if you guys change operations in the field, you know, perhaps that changes how you detect the slip.
Yeah, I think it definitely is a concern and to watch for. One of the things, we're really happy with the initial results, but as processes change and as we go into different basins, like it's amazing how different each of the basins and even how the different oil companies do their completions. So it is a real concern. I have to make sure we get a whole bunch more guide hawks in the hole and paid for, and then I can afford to do some additional analysis on that. There really is, though, a diminishing return on the cost, though. You know, how much analysis is going to be way more expensive. You know, with this project, we're going to be able to recoup the cost of it, but you know, if we had to spend $2 million to pay attention to the drift, there might not be a return on that. Cool. All right. Thank you very much.